This is section 14.2, the distance formula. Okay, so the first thing that we're going to start with is the activity that's on page 606, so flip to that, and it's kind of at the bottom of the page there where it says, we're supposed to graph that stuff. So what I'm going to do is I'm just going to take a piece of graph paper and work through this activity. So the first thing it wants us to do is it wants us to graph some points, so I'm going to start with a coordinate plane here. So looks like I got to go up to at least 5 both ways, so I'll just kind of make myself a graph here. Okay, something like that. And then it wants us to graph the points. M is at -4, 3. So M, -4, 3. So 1, 2, 3, 4. Up 3, 1, 2, 3. That is M at -4, 3. And then N is at 2, -5. So over 2, down 5. 1, 2, 3, 4, 5. Stick a point. And that is our N at 2, -5. Okay, so then what they want us to do is they want us to draw a vertical segment from M and a horizontal segment from N and label their intersection point P. So basically what we're going to do is we are just going to kind of extend these lines out here so they end up crossing each other and kind of making a triangle. I'm just going to extend that out like that. And this one I'm going to extend down just like that. So that's the next step. And then, what's it say? Find the coordinates of P. Okay, so we are supposed to find the coordinates of P. So P would be this spot right here, which would be, looks like it is at 1, 2, 3, 4, -4, so this is point P, at -4, and then looks like it would be going down 5, so -4, 5. Okay, so what we want to do here is we want to use Pythagorean theorem to figure out our distance between these 2 points M and N. So basically I'm going to draw a line in here from M to N, and our goal is to figure out how long that side is. Okay, so what makes this kind of tricky here is you can't just count up your sides because you don't necessarily have like full squares here. So you got like a part of a square there, a real tiny part of a square there, and so on, and it's not full squares like it is on the sides. So what we're going to do is we're going to use Pythagorean theorem, and we're going to think about the side lengths. So we know that this is a right triangle because we're on a coordinate plane here. Then we take the sides of our legs, or the lengths of our legs, which would be 1, 2, 3, 4, 5, 6. Looks like that bottom side is 6 units. And then our other leg up the side here would be 1, 2, 3, 4, 5, 6, 7, 8 units. So then what we want to do, our Pythagorean theorem, I'll write it off to the side here. So Pythagorean theorem. That formula is a squared plus b squared is equal to c squared. A and B are our legs, so like our legs here would be the 8 and the 6, and the C is the hypotenuse, the side that we're trying to find. So the C is always opposite the 90, that diagonal there. So what we do is we take and we plug in our information. So we've got 8 and 6 as our legs, so we're going to go 8 squared plus our B is going to be 6, so 6 squared is equal to c squared, and then we just solve this out. So 8 squared would be 64, 6 squared is 36, it's equal to c squared. Then I would add 64 and 36 together, which is 100. So 100 is equal to c squared. And then when I need to solve this, to get rid of squaring something, I do the square root. So to get the c by itself, get rid of the squared, I'm going to square root both sides. So that I'm going to be left with c here, and then square root of 100 is 10. So my length of this side here is 10, which tells me that my distance between m and n is 10 units. Okay, so you could use Pythagorean theorem in a graph to figure out the distance between 2 points. Okay, now I'm also going to show you another thing that you can use. So you can use Pythagorean theorem. It might take you a little bit longer to graph out the points and then do all that stuff. So what we can also do is we can use something called the distance formula. The distance formula is going to use 2 points here. So we've got x1 and y1, x2 and y2, so just an ordered pair and an ordered pair. And what we do is we take your x's and subtract those, then square that value, and add that to your y value subtracted, square that, and then once you get those values added together, then you take the square root of the whole thing, and you get your distance between the 2 points. Okay, so let's try this here. So our 2 points here are E and F. So E is at -3, 8. F is at 5, 1. So if we use that formula, let's go x and y, x and y. Okay, so I'll have my distance is equal to square root of, and then I take my 2 x points and subtract them, and the order of these doesn't necessarily matter as long as your x's are together in the same group and your y's are together in the same group. The order of them isn't terribly important. So your x's, you've got -3 minus, always subtract in between, and then your 5 for the other x, parentheses squared, plus, parentheses, and then your y subtracted, so 8 minus 1 squared. So then what we do here is we just kind of start simplifying. So I would start inside my parentheses. So I'd go, okay, I'm going to still have square root. Inside my parentheses there, if I did -3 minus 5, that's -8. Parentheses squared plus 8 minus 1 is 7 squared. Then I would actually take and square those values, so still got my big square root there. -8 squared would be a positive 64 because it would be a -8 times a -8, which would end up being positive. It's positive 64 plus 7 squared is 49. And then if I add those values together, I get square root of 113. So depending on what they ask, if they ask for an exact answer, you would want to leave it at that. If they ask for an approximate answer, because this doesn't come out nice, what you could do is just do it on your calculator. So second square root 113, which is 10.63. So you could also put that it's approximately to 10.63 units. Okay, so if you kind of notice there's some similarities between that distance formula and Pythagorean theorem. So basically you're kind of working the same types of steps, but instead of doing it out as an equation, you're doing it all as one thing. So you've got, your x values being squared there, your y values being squared, so that's kind of like the a squared and the b squared, and then that big square root is solving for your c, where we did the square root there and the square root there after we added those values together. So it's really kind of similar to Pythagorean theorem, it's just working it backwards. Okay, so let's try another one here. So this one says that there's a picture on 606, so maybe we should look at that. So it looks like a map up there in the corner of Washington, D.C., and it says 2 taxis leave the intersection of, I should just put this map up here. Okay, so 2 taxis leave the intersection of 15th Street and G Street. So 15th Street is this one here, and G Street is this one going across this way. So basically the taxis are leaving from our 0, 0 or our origin. And then it says 1 taxi travels 7 blocks north, so the one's going 7 blocks this way. and then the other is traveling 11 blocks to the east. So east is this direction, it's going 11 this way, and we're supposed to figure out how far the taxis are apart when they stop. Okay, so let's sketch our own picture out here so we can do some solving. So if I've got something kind of similar to what they had, my starting point is going to be at 0, 0 because that's where those two taxis are. You got 15th Street and G Street. And it says the one taxi is starting here and going 7 blocks north. So 1, 2, 3, 4, 5, 6, 7. So that's where the one taxi is going. The other taxi is going east, so that would be off to the right here, and they're going 11 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And what they want us to do is those taxis are going to stop, and we want to find the distance between those. Okay, so this point here would be at over 11 up 0, so 11, 0. This point here would be up 7, or it would be over 0, so 0 for the x and up 7 for the y. And it's up to you. You could use Pythagorean theorem on this to figure out that distance. So like this side would be 11, this side would be 7, and you could do all the stuff there. Since we're working on distance formula, I'm probably going to use distance formula on this just to show you, but you could also use Pythagorean theorem on this and get the same thing. Okay, so let's solve it out here. So I'm going to use that distance formula. So distance is equal to big square root. I got my x's subtracted from each other, add them together, or x's subtracted and then squared in parentheses. So my x's here would be 0 and 11. So 0 minus 11 for my x's subtracted plus my y's subtracted would be 7 and 0. So 7 minus 0 squared. So then if I solve that out, 0 minus 11 would be negative 11. So negative 11 in parentheses squared plus 7 minus 0 is 7 squared. And then if I keep going there and actually square those, negative 11 squared would be 121. Positive. 7 squared is 49. And then if I add those values together, I get that my d would be equal to the square root of 170. And then again, that doesn't really come out nice. So we'll do an approximation here as well. So if I did on my calculator second square root of 170, I get 13.038 whatever. So I'm going to go, let's go 13.0, we'll just round to 4. So that's what our distance would be approximately equal to, and we are measuring this in blocks. Okay, so that is all for the notes. So you've got the book page 609, 10 to 17 all.